All right, now let's look at some composition where we possibly might have domain change. Now remember how a little bit earlier I said if their domains are different, then your domains might change when you put one together. Here's what I want you to know. This is a parabola because our x is squared, which means the domain is x is an element of the reals. This one, however, is a square root. Remember, a square root kind of looks like this. Let me put that on here. This one's u. Okay, so this is a square root. Usually it starts at 0. This we learned is transformation shifting at left 1, which means this one's domain is from, excuse me, I said left 1. It's right 1. It would be right 1 to infinity. Notice how they're different. Because of that, we're going to have to check the domain at the end. All right, so that's what we'll do at the end. Now, here's how this works. We want to do f of g. That means g goes inside of f. So I'm going to write out f is equation. And I'll just use the shorthand abbreviation. But instead of x, I'm going to replace the x with x minus 1 quantity squared. That's where g goes. G went into all of this, goes right there into x, and then I put the minus 1. To simplify this equation, I will need a FOIL. So I have x minus 1 times x minus 1. And that, when I FOIL it out, would be x squared. That's at first times first. Outside times outside is negative 1x. So I can just say negative x. And the inside times inside is negative 1x. So again, negative x. And then negative 1 times negative 1 is positive 1. When I combine those, I will get x squared minus 2x plus 1. And then, of course, I have the green minus 1 from earlier. And again, when I simplify this one more time, I finally come up with my answer. I have x squared minus 2x. Now that is f of g. Okay, there's my equation. Now, let's check this domain because we might have, since we have a different domain to start with, my domains might change when it's together. Here's how you're going to do this. You're going to go to your calculator, add a graph. And you're going to type in equations exactly as they appeared. So I want to first type in f, which was, if you remember, square root of x minus 1. And here's our square root, just like we said it was going to be, to the right one. Then I type in the other equation. It was x minus 1 quantity squared. There's our there's our parabola and our square root. And here's how you do f of g. So on this third equation, so this is f, this one's g. We're going to put, you're going to write f1, referring to the first equation here. And then instead of doing x in the parentheses, you'll do a parentheses. You're going to put f2 inside of it because the g goes inside the f. And then you put your x. So we have f1 with the function f2 inside. When I press enter, I get this image here. Now I want to take a picture of this real quick. And I'm actually going to move some of these names around so you can see them easier, the labels. Okay, now that I have that, I'm going to take a picture of this. And we're going to come back over here. I'm going to paste it. And now that I've done that, I'm going to point out that this graph is this equation here. And now we're going to look at the domain. It appears that it exists going left forever and right forever, but there's a gap between 0 and 2. Is that where it's coming from? 0 and 2, it looks like, is where we have a problem. So anywhere between 0 and 2, this graph doesn't exist. Now we need to check and make sure if I needed a closed dot or an open dot on those values. So I'm going to come over here, press Control T. And we want to check at 0 and 2 if the values exist. Whoa. And this is the first function. We don't want the first function. We want the third function. So I'm going to go over here. And I'm going to see that at those points, I'm sorry, the graph does exist. All right, so what does that mean for us? Let me go back to over. Okay, here's what this tells me. On this third equation here, we have values that exist at 0, 1. So this would be closed dot, and this is an arrow and there. So when I do my domain, I would say the domain, I go from negative infinity to 0, and that 0 needs a bracket because it exists on a table. And then I would also go from 0, or excuse me, from 2 to positive infinity. And you could rewrite it as saying, I'm sorry, x is less than or equal to 0, or not, or, and, no, or 2 is less than or equal to x. And that's how you'd write the domain. What that means is, on the f of g equation, if you plugged in a number that's not existing, like say 1, it's in between there, we should have a problem. Let's see, 1 squared is 1 minus 2 times 1, which would be 1 minus 2. 1 minus 2 is negative 1. You cannot take a square root of a negative number. That's why that value does not exist. So even though the original domains were all reals on one of them, and this one was 1 to infinity, we find out that the new domain is x has got to be either less than or equal to 0 or greater than or equal to 2. Let's try another one of these with these two equations. So again, this domain, if you think about this picture, it would look like this. It's the reciprocal graph, so it's going to be like this. And there is a asymptote there, so you on 0, so you'd say that x cannot equal 0. It's all their numbers though. Okay, so I wrote that in set builder. Here, we'll have to talk about, this looks a lot like the equation we just had. This domain is going to be different than that because a number like 0.5 squared is less than 1, and we frequently have problems. So again, we're going to have to type in the equations to each other. So let's do f of g. So we're going to plug in our g equation into f. So f of g would equal 1 over the square root of x squared minus 1. So there's our graph, or there's our equation. So now let's graph these. So I want to graph these real quick. So remember the first graph was just 1 over x. And my next equation was the square root of x squared minus 1. Okay, so there's my graphs. And now we're going to find the third equation. So we go tab, and on the third equation, I type in f1, parentheses f2, parentheses x. Press enter. There's my third graph. Now that I got them graphed, we can check out the domain. It looks like there's a vertical asymptote here. We're looking at the black one. That's the third equation. So you'd say the domain here is that it goes from negative infinity all the way to 1. But since it's a vertical asymptote, you're never equal to it. You just approach it. So I put a parentheses, and that's negative 1. I'm sorry, negative 1. And then it picks up again at positive 1 and goes to infinity. Or you could write it this way. You could say that x is less than negative 1, or 1 is less than x. That's how you would write this. Now it's your turn.